So today we're moving on to a slightly different type of problem. Looks something like this. Let's say you have a circle with a diameter of 120 millimeters. And I have these tangents here that create, let's call this 100 millimeters across the base here. I want to find this is one of those problems. It's actually way simpler than
from cell phone.
So we have our radius to a tangent here in three spots, so radii to tangents. You know those form right angles. And of course, we have our little trick of connecting the center of the circle up to our intersecting tangents. So we have now created four right triangles there. We know that this side of this triangle is how long? 100 millimeters. Half of the 200. If that's 100 millimeters, how long does this have? We know that two tangents that intersect have the same length. The tangency to the point of intersection. So that means all of these triangles are 100 millimeters over here. And of course, this would be 60 millimeters. Radius, all of them. So we have four, the technical term is congruent triangles. They're all four the same. Find the area of each of those. I label that shape 1. All four of them are same shape. Simply going to be 100 millimeters times 60 millimeters. How do I know that those are the two dimensions that I multiply? The area. For the base and the height. They're the two legs of the right triangle. Remember, to find area, we have to have two dimensions that are perpendicular. It's always the two legs. And of course, we multiply them and divide by 2 because it's a triangle. We will then multiply that by 4 because there's 4 of them. I believe that comes up to 12,000 millimeters squared. All that is missing now, find the area of this piece here. Find that area. So this central angle. Find that central angle. Got to know this one. Because that's the same all the way around there. Those 4 are all the same. That angle, I'm going to label it angle alpha. I have a 60 millimeter side, which would be what side for alpha? The 100 millimeter side would be the opposite side. So that's going to be a tangent. Tangent of an angle is the opposite side of the adjacent side. Don't know the angle, so we'll put alpha in there for the angle. Opposite side is 100, adjacent side is 60. How do I find that angle? inverse tangent of 100 over 60. Giving us 59.04 degrees. We said there are 4 of them here, so I'm going to multiply that by 4. And notice I'm going to leave it in my calculator because that is rounded. It's actually 59.036. I'm going to do times 4. Gives me 236.14. Degrees. Means here 4. Now, how do I go about finding the area of that sector? Circle there. Perfect. Pi times 60 squared times that angle of 123. 3889.20. Add those two together, 15,889.20. What do you think? Stuff? We're gonna have some fun with measurement here. I want to know the mass of this object. Given that the density is 0.21 kilograms per centimeter cubed. I know that is not a mistake. Would have been way easier if I gave it in pounds per cubic inch rather than kilograms per cubic centimeter. But I want to make sure we can make that conversion. For some reason, I get it, it's because of the decimals. This problem becomes way more difficult when we do it in inches than it was in the version we did yesterday in millimeters. Millimeters being a smaller unit, you have larger numbers. A lot of people find that easier to absorb just because it's more convenient numbers. But it's exactly the same process. I have to find the volume of this. I can find the volume of the whole box without the groove taken out. This 4.5 times 1.8, 1.2. That's 9.72. But now we have to figure out the amount of material that's been removed with that groove that's cut in. To do that, I have to look at this. Out of which, taking this groove, first of all, what's this dimension right here? .55? That was just the whole depth of 1.2 minus that 0.65, right? And of course, going across here, each of these pieces is going to have a dimension of what? .1. Half of the 2.2. How do I find this dimension x? Solve that by multiplying the 1.1 times 1.1, dividing by the 0.55. X equals how do I find the diameter of that circle? Perfect. We add the 2.2 and the 0.55. It was 2.75 for that circle. Means the radius of that circle is perfect. Half of the 2.75 gives us 1.375. We have a radius. Radii oh. So this distance here, 825. How did I find that? Radius is 1.375. I can find the area of the triangle. Base across here is 2.2 times the height, 0.825, and of course it's a triangle, so it's divided by 2. Here's 0.935 square inches. That's the area of the triangle that has to be taken out. I also need the area of the whole sector. What piece of information do I still need before I can find that? I need this angle. How am I going to find that angle? That right triangle that's half of that, right? It is this angle up here. What trig function are I using? Opposite and hypotenuse. It is sine. Sine is equal to 1.1 over 1.3. So the angle is the inverse side. (53.13 degrees). And now we're going to have to multiply that times 2 because there's 2 of them together there. 106.26. Now how do I find the area of the sector? Pi 3.14 times 1.375 squared times 106.26 divided by 3. Give us 1.752. The area of the segment remember the segment, that's just this piece out here, which is the groove that's cut out, right? It's going to be 752 minus 0.935. Giving us a difference of 7. So what's the volume of that channel that's been machined out? How do I find it? My area, the cross-section area of 0.817, that's this area right here. What do I do with it? By that length of area of 1.471. Sorry, not area, volume of 1.471. Now I have to subtract that out up here of the volume of the whole box. .249 cubic inches is the volume of the box, or the volume of the whole object. So 8.249 cubic inches. Remember, we have a density 0.21 kilograms per cubic centimeter. What that density means is I need to convert this volume into cubic centimeters rather than cubic inches. How do I figure out how many cubic centimeters are in a cubic inch? Cubic inch, of course, is 1 inch by 1 inch by 1 inch. Anybody remember how many centimeters are in an inch? 0.54. 0.54 centimeters by 2.54 centimeters by 2.54 centimeters. 16.387 is where we're going to round it centimeters. 1 cubic inch. Now, while we're at it, cubic inches have canceled out. We just want to convert this into kilograms while we're at it. We're going to put cubic centimeters on bottom here. 0.21 kilograms is equivalent to 1 cubic centimeter. Cubic centimeters are going to cancel out. So we have 8.249 times 16.387 times 0.21. We get 28.387 kilograms, the mass of that piece. Like I said yesterday, what we've done here involves nothing new. Known all this before. It's the matter of combining all this stuff together. That's really, once you get out of here, the problems you're going to encounter at work, that's what they're going to be. They're all going to be math concepts that you know. It's just a matter of figuring out which ones to apply and in what order to get to a result. Here's a new worksheet in Blackboard that resembles the first problem we did today. You guys have our